Late nights, telephones. There it is. Yeah, there it is. Really, only 2.3% of my CPU. I could have a way higher bit rate if I wanted to, but I don't really need it. So, okay. So that's the subset sum problem. What are the famous stream ciphers? RC4 and Salsa 20, I guess. I know it's riveting looking at the top of my head. Stream ciphers. It's like RC4, Salsa 20. Yes. RC4, that's the easy one. eStream. No, Salsa 20. Sosimanuk. And then Sosimanuk. Sosimanuk. What is semantic security in the one-time key setting? What is semantic security in the one-time key setting? Semantic security. How to define it in like real terms? Well, the definition of semantic security is the probability or the advantage that the adversary can predict the next bit in a sequence, predict the value of a bit in a sequence given your fucking ciphertext. So hold on, let's go to the semantic security of one-time pad and stream ciphers. Semantic security. What is a secure cipher? Shannon's perfect secrecy. Define computationally secure as follows. Let ED be a cipher over the key space, message space, and cipher. Scheme is perfectly secure if for any message 0 and message 1 defined in the cipher space, the cardinality of M0 is equal to M1. The encryption of M0 is the encryption is equal to the same encryption where K is random and is a random key in the key space. The encryption scheme is computationally secure for any for all M0, M1 defined in M. The cardinality of M0 is equal to M1. Is P is what does that mean? The probability is equal. This computation is we could define. We saw it before. Semantic security, 2 experiments, X0, 0, and experiment 1 as the experiment 0, the adversary is given an output encryption of M0, output of encryption M1. Experiment B is equal to B prime denotes that A outputs it a guess bit B prime. For B1, 0 defined experiment A0. As for M0, M1 defined in M, the cardinality of M0 is equal to M, where the cardinality of 0 1. The semantic security would be described as given an adversary in the encryption scheme is the probability where WB is equal to the event that experiment B is equal to 1. So experiment B equals 1 minus experiment B equals 1, which means where if B equals 1, that means that he gets it right. Is equal to defined in 0 and 1. Note that in the notation for the semantic secure advantage, the letter E denotes the cipher. Yeah, we know. I know that. No, my review. Late nights, telephones, calling all the wallflowers. I don't know why, but that song's been stuck in my head. I only have 2 more homeworks in this class, which is hype, but like cryptographic hash functions. I love cryptographic hash functions. They're my favorites. How to show that one-time pad is semantically secure? Well, it's simple. One-time pad is semantically secure because it's the probability that you choose one of the key spaces very low, like the key space. Yeah, whatever. How to show that a stream cipher is semantically secure. What is a block cipher? What are the famous block ciphers used currently and in the past? A block cipher is a cipher that takes blocks of text from the message space and XORs it with a pseudo-random and XORs it with a key. And it takes. How does the DES cipher work? The Feistel network. A Feistel network is an encryption scheme that allows you to use a uninvertible PRF or PRG, PRF or PRP, PRF, an uninvertible PRF, because the Feistel network itself is invertible. It does not. It means that you can use a PRF to get your key that is not necessarily invertible. How to show that a stream cipher is semantically secure. Well, that was easy. It's just the advantage of the key space and whatever. And like it just breaks down to like the advantage of the PRG that you have. What are the famous block ciphers currently used? DES, double DES is vulnerable to meet in the middle attacks. Triple DES and AES is the current one. How do S boxes of DES work? Why should they not be linear? The substitution boxes. Okay, so DES works as DES. I fucking hate DES. It's like the one block cipher that like nobody uses because it's super complicated, and that's why I don't want to know how. Fucking DES, yes, DES discussion. Widely deployed in banking and commerce. A machine was able to search all 256 keys to recover the actual key. Crack.s, yeah, it's broken. It's a broken cipher. Core idea is the Feistel network. Given arbitrary function, like pseudo-random function, F1, FD, where you get a permutation of your bit string, right? Not a permutation, but like a... Yeah. Build an invertible function, F, for 2n to 2n, right? So your input is you have your right and your left block, and you have this is the input for the right block is the input for the pseudo-random function. The pseudo-random function gets XORed with the left, and then this becomes the left block becomes the right block for the next one, and the right block becomes the next block. Like, so you do this, and then this gets XORed, and then it becomes the right block, and then this gets XORed all the way up, and you do a full round of, I forget how many rounds are in DE. I think it's 16. For all F1 through FD, the Feistel network, F0 to 2n to 2n is invertible. And it's invertible, even though your pseudo-random function isn't invertible, because fuck it, right? For all Feistel network, prove, construct, inverse. Claim for all F1 through FD defined as a 0n bit. The Feistel network is invertible. Proof, construct, inverse. Yeah, the inverse is that. Decryption circuit is just you do the inverse of everything. Inversion is basically the same circuit with F1 FD applied in reverse order. Appealing for hardware designers. Encryption hardware is identical to decryption hardware. Just the order of the functions is opposite. Yeah, we did the decryption. We know the decryption. General methods for invertible functions. Block ciphers are from arbitrary functions used in many block ciphers, but not AES. Yeah, 16 round Feistel network, which is a DES. Round functions, DES from 1 to 32. The F, like the function is 116, so the block size is 64 bits, right? Or the output is, the input 64 bits. Final permutation, 16 round Feistel network with key inspection. Because we love key inspection. How do the S boxes work? Plain text half a block, you get encrypted, you get the 48 bits. And then your K at I, which is the key expanded from your F. You XOR it together, and you get 48 bits, and this becomes a 32-bit. 48 bits, and then you go bonk, you go from S6 to 4. What was the question asking? How do the S boxes of DES work? Why should they be non-linear? So that how are the S boxes chosen? Why should they be non-linear? Because if they're non-linear, well, if they're linear, then the you could tell what the input was of the S box based on the output. If they were linear, if they were 1-to-1 or linear, then you could tell like, hey, this this S box produced this or took this input, which means that we XORed it with this. What are the famous block ciphers used currently and in the? Oh no, we're done. What is the exhaustive key search attack against a cipher? It's where you exhaustively search all the keys in the key space. What resource does it take to break DES by exhaustive key search? I believe it was like 2 to the 48. DES was broken, right? DES challenged by RSA. Find key. Yeah, it's like investment at $250,000. Copacabana, 10K, 26 hours. It's like the cost for is the equivalent key size. Well, the key size for it's like 1 to the 56, which is not very, not good. 20 blank crack.sh is 26 hours. 48 FPGAs. I don't know what FPGA is. Turns out choosing S boxes and P boxes at random would also result in a secure box. Okay. So triple DES is 112 bits. The equivalent key size. Like 26 hours of time in a shell script. That's how much it takes. How to strengthen triple DES using the triple DES. Strengthening the DES is you iterate DES 3 times. So you literally just have 3 keys. You do 3 EDES. You do 3 DES. You have 3 keys, message to message. That. It's 3 times slower than DES, but I mean shit. You get a better key size. 3, simple attack in time, exhaustive search. The equivalent key size is 112 bits. So my ears fucking up. Triple DES 112 bit disallowed. DES is now allowed. The AES is the main cipher that we use now. Why is double DES not effective? How does meet in the middle attack work? Meet in the middle attack, basically what you do is you iterate over the second one. You iterate all of the... You brute force exhaustive key search for all of the... Since this is PRP, I believe, it's 1-to-1. You iterate all over the second the outputs of the inputs and the outputs of the second DES, and based on the output of the first DES, you can then, meet in the middle, and you can decrypt it. Why is double DES not effective? Because it's meet in the middle. What is the equivalent key length? What is the equivalent key length of AES? DES is 112 bits. 56 times 8 bits are parity check bits. So yeah. So equivalent key size is the amount of attacks. Is the power of attacks of operation is the number of operations logged to operations it takes to crack it. How does AES cipher work? What is the substitution permutation network? The AES cipher, NIST publishes request for approval, 15 submissions. NIST chooses 5 from Rindel AES, designed in Belgium. Key sizes are 128, 92, and 256. The block size is 128 bits. Larger size is equal to more secure as a pseudo-random permutation. Larger number for rounds is slower performance. But electronic codebook, plain text is divided into blocks, and each block is encrypted separately, uses the same PRP. M1 is equal to M2, then C1 equals C2. Attacker learns about M1 and M2, block cipher modes of operation. Discussed in detail in the next class. Yeah, the modes of operation, we know that. What did you want the answer for? What is the substitution permutation network? Oh fuck, that was the wrong one. Close. block cipher modes of operation. Pseudo-random functions. DES is retired because it's fucking shit. YS2 DES, AES, and overview design. Abstractions of block ciphers is a pseudo-random function and pseudo-random permutation. Triple DES was used, but double DES, yeah, the meet in the middle attack, this one. It's like if you iterate all 256 entries to a separate key, then you can do that, and then, yeah. Meet in the middle attack. The equivalent key space is 256, right? Now, you want the linear and differential attacks. DES exists because of a bug in design S5 box where theta is equal to 1 over 2 to the 21 or around 1 over 7. I have this shit a little bit. Theorem, given 1 over epsilon squared random. I don't need to know this. Linear attacks. Do I need to know linear attacks? Please tell me I don't need to know linear attacks, because I hate it. How does electronic codebook mode work? They're encrypted using the same PRF, so you break up M1, you break up the plain text and the ciphertext into blocks. And they all use the same. They all use the same pseudo-random function, so that way, if M0 is equal to M1, then C0 is equal to C1. So the attacker will know about M1 and M0, or M0 and M1. How does the equivalent cipher substitution permutation network do? It's like, oh yeah, I see. So I remember this now. So you XOR your input with your key 1 that you get from your key expansion algorithm, which is just a giant thing in the sky that we don't know much about, but it gives us these keys constantly based off of 1 seed. And then you feed it into some S boxes, substitution boxes, where you are substituting an input for an output, and then you permutate them around, and then that becomes your input for the next round, and then, yeah. It's not a Feistel network. There was a scene in fucking, like, this is, I know I'm talking to nobody right now, but there was a scene in that new movie Argyle where Samuel L. Jackson is trying to, like, decrypt an algorithm or some shit. He's like, there's like encrypted data, and they just like, it's like, oh, it's a Feistel network. It's a, oh god, it was like a Katie algorithm. Hold on. Different Feistel network encryption schemes. It was like Katie. Feistel block cipher. Yeah. What are Feistel? I know about the Feistel cipher, but like, hold on. Was the encryption scheme in Argyle, and he made it seem like, okay, so Samuel, like, Argyle ending explain. Agent Argyle, yeah. Reader sits call down, yeah. Okay, I'm trying to, like, whatever. It was something like the Katie algorithm or some shit like that just doesn't exist. It's like it's a Feistel network, and it's just like one of those words that they say to make it sound, good in the movies. But I was watching that shit, and I was like, I had literally just got yesterday. I watched it on Friday, and my crypto class is on a Thursday, and we just got done learning about Feistel networks, and it's like, it's a Feistel network, and I'm like, I can't get away from this shit. Like, I can't get away from cryptography. I don't know, I just thought it funny because like Samuel L. Jackson made it seem like decrypting a Feistel network was like a matter of intellect and skill, and like, oh, I'm so smart, like my old nemesis, this Feistel network encryption scheme. And in reality, you want to know what decrypting a Feistel network looks like? You want to know what decrypting a Feistel network looks like? It looks like this. It looks like this. Like this is decrypting a Feistel network. Decrypting a Feistel network is quite literally just brute forcing over the key space. If it was DES, look, you ready? DES, all you need is this. All you need is that. You need a script called crack.sh. It's a shell script. Online service providing access to 48 FPGA array that can exhaust the DES key space in about 26 hours. That's all you need. I don't know, like, hold on, I have to figure it out, like, are some Feistel encryption schemes. Feistel encryption. Feistel network encryption. Feistel network. God, my typing shit. Encryption schemes. Feistel blocks. Yeah, I know. It's just, what are some that use the block the? Okay, let's look up some. What are some common block ciphers? Ciphers. Notable block ciphers. You have Lucifer, DES, data encryption standard. Yeah, no longer there. IDEA, RC5 is probably dead. AES is the big one. Blowfish. Blowfish? What is Blowfish? What is the block cipher? Shire and included a large number of cipher suites and encrypted products. Blowfish has a 64-bit block size and a variable key length from 1 up to 448 bits. It's a 16-round Feistel cipher and uses a large key-dependent S-boxes. Notable features of the design include key-dependent S-boxes and a highly complex key schedule. It was designed as a general-purpose algorithm intended as an alternative for the aging DES, free of the problems and constraints associated with the other algorithms. At the time Blowfish was released, many other designs were proprietary and covered by patents or were commercial/government secrets. Schneier stated that Blowfish is unpatented and will remain so in all countries. The algorithm is hereby placed in the public domain and can be freely used by anyone. Two-fish successor. Okay, and then AES is like the normal one. AES is the one everybody uses now, so that's cool. Anyway, that's enough with that Argyle thing. I just need a little break. What is a pseudo-random function? Forget. What is the pseudo-random function? Abstractly is a pseudo-random function. A pseudo-random function is defined over a tuple key x and y, where key cross x is defined as y. Where key is the x space, y is the input space, x is the input space, and y is the output space, such that there is an efficient algorithm to evaluate f of x. F does not have to be invertible. Abstractly, I should probably text my girlfriend.
Just 19. Signing off a student on their mega code. One of the things I always test.
Yeah, I'm a texter. Okay, I'm gonna put the phone down because I don't need it. Pseudo-random permutation defined over the key space and the input space, where the key space, input space, and the output space, such that there is an efficient deterministic algorithm to evaluate the encryption given a key and x defined in the x space and the key space and the input space. The function encryption key in any x is 1-to-1. Pseudo-random permutation. A pseudo-random function. Okay, so pseudo-random function f is not invertible. Does not have to be invertible. However, for pseudo-random permutation, there also exists an efficient inversion algorithm. So, aka a decryption algorithm. Knock that in your brain. Like, there's a inversion for this. The difference between a pseudo-random function and a pseudo-random permutation is that a pseudo-random function does not have to be invertible, but a permutation does. Note that E is 1-to-1. That for any output, there's a very specific element in the output space. There is an input for any given output. Abstractly, a PRP. Pseudo-random permutations are exact representations of block ciphers. Pseudo-random permutations of block ciphers are used interchangeably. PRPs, DDES, AES. Functionally, any PRP is also a PRF, where PRP is a special case of a PRF, where x equals y and that is efficiently invertible. Secure PRF. Consider the following. Intuition. A PRF is secure if a random functions is indistinguishable from a random function in SF. The number of all possible functions. How many functions F1 and 0, 1 are possible? Example. Oh my god, this shit's so fucking... Makes me want to punch a brick hole in a wall. How is its security defined? Pseudo-random function is secure if a random... Okay, all I have to know is that a pseudo-random function is secure if a random function in the functions of the input... So S of functions is the set of all functions from x to y. Great. If all functions is the indistinguishable from a random function. And S of S. S sub F. How many functions 1 through n 0 to 1 possible? Let F be defined as a pseudo-random function. PRF is secure if a random function, yes, great. Pseudo-random permutation. A pseudo-random permutation is defined as a secure PRPs. Question. Is G a secure PRF? Be a secure PRF. Is the following G a secure PRF? No. It is too easy to distinguish G from a random function. Secure PRPs. Intuition. A random function in perms x, the permutations of x is indistinguishable from a random function in S of S. S sub F. Secure PRP. Here's the experiment for the semantic security game for secure PRP. Adversary, challenge, challenger. We give it any amount of chosen plain texts, key in our pseudo-random function, right? B0, B0, and then F is also perm. B1 is experiment. B1 is the permutations of X, and then this is like random, right? It is defined as secure for all efficient adversaries. Then the probability that it can tell the difference between the probability that it can tell the difference between a random function and a pseudo-random permutation is, or one of the permutations in X is close to 0. Okay, negligible, which is 2 over 2 to the fucking 32, I think. What does the PRF switching lemma imply? PRF switching lemma imply. How does the PRF? Block ciphers mode of operation. It's just a way to determine the nonce value. Or like the IV, we have. It's just a way to like have it use a many time key almost. It's kind of what it is. How does an electronic code book mode work? We already did that. What is the disadvantage in terms of security? Lovely. More. Great. Modes of operations. PRF implies PRG. Yes, that is mode. Key properties. Parallelizable. Generator G gives us a parallelizable stream cipher. Example is the design of the salsa cha-cha family. Note, however, that it be above construction is generic. It works for any PRF. How about PRP? Can we distinguish from the output of a PRP from a uniformly random string? Yeah, we can. Totally. PRP is indistinguishable from a uniformly random string if its size is large enough. Yeah. Okay, I'm gonna have to fucking shit my brains out here. Okay, we're back. PRF switching lemma. Any secure PRP is also a secure PRF if X is sufficiently large. I don't know why how about a PRP? Any secure pseudo-random permutation is also a secure pseudo-random function if the modality of X is sufficiently large. Let E be a pseudo-random permutation over K of X and any K query adversary. Then for any K query, the advantage is less than Q or negligible. There's a PRP switching lemma. Lemma. Let E be a PRP over K and X for K query adversary. E be a PRP over K and X for any K Q query adversary A advantages of PRF A and E. Suppose that X is large so that Q squared over 2 modality X is negligible. The advantage P pseudo-random permutation A and E negligible. The advantage PRF A and E is negligible. Let's go look at the practice questions based off of 2023 version and see if I know the. Suppose that the message cell is encrypted using the Vigenère cipher with a 4-letter password. The password is not known, but it can be any combination of English letters, not necessarily a meaningful word. The resulting cipher could be literally any of them. Make an incorrect statement. When the key is an all-zero vector, that is correct. The key length must be equal to or exceed plaintext length, yeah. If the plaintext is 0101, the respective ciphertext is 0011. Yes, that is true. Successful exhaustive key search attack against cipher results in 2 n operations where n is the key length. That is not true. It is 2 to 2 to the n. It would not cause. It would cause 2 to the 2 to the n operations. Make an incorrect statement regarding pseudo-random generators. Pseudo-random generator is a deterministic function where the input is a seed. Yeah, we know that. Pseudo-random sequence must be unpredictable. Yes. Cha-cha-20 can be used to generate cryptographic randomness. That is very true. For a secure PRG, the advantage of distinguishing its output from a random string bit must be non-negligible. For a secure PRG, the advantage of distinguishing its output from a random bit string must be non-negligible. Must be negligible, not non-negligible. Must be negligible, not non-negligible. Negligible. Mark an incorrect statement regarding stream ciphers. Cha-cha-20 is perfectly secure. Cha-cha-20 is using internet security protocols. It is not. Key stream must be unpredictable. The stream cipher is secure if the underlying PRG is secure. That is not true. Cha-cha-20 is perfectly secure. Mark an incorrect statement. Actually, yeah, mark an incorrect statement. Cha-cha-20 is not perfectly secure. Mark an incorrect statement regarding a pseudo-random permutation PRP. Mark 1, answer which fits best. It is an ideal model of a block cipher. Mark an incorrect statement regarding a pseudo-random permutation. Pseudo-random permutation. I mean, it is an ideal model. It must be invertible. Yeah, pseudo-random permutations are invertible. Otherwise, it's a pseudo-random function. The output space is the same as the input space. That's true. Otherwise, it's not a permutation. It's like a function. It's a generator, or yeah. Security does not depend on key length. Security does depend on key length for a pseudo-random permutation because the key length's too small. Then you can just do a brute force attack on it. Mark an incorrect statement regarding pseudo-random function PRF. 5 bonus sheets of the exam sheet is submitted. Total sum 130. Oh wait, you get. Oh, I didn't notice that. I don't actually have to get 100 on 100. If I get 130 on the exam, though, can I, like, possibly maybe get some bonus points? Okay, of course they're being crazy. Dude, he's such a fucking stoner. It's weird. He's such a huge stoner, bro. He's gotta stop doing that. Smoking weed's not good for you. Especially as a comp sci major. Like, start fucking studying. Holy. You should switch majors. Mark an incorrect statement regarding a pseudo-random permutation. We did that. Mark an incorrect statement regarding a pseudo-random function. Mark one answer which fits best. Oh, crap, I gotta do that. Make an incorrect statement about DES. It's a block cipher, that's true. Block length is 64 bits. The design is based on a Feistel network, and double DES is definitely not recommended for strengthening its security. DES does not make it more secure. It just doesn't do anything. Meet in the middle is the thing. Mark a function which operates byte sub implements in AES. Substitution. Yeah. Not the permutation, shifting, or it's just the substitution. Byte sub substitution. Mark an incorrect statement about AES. Key length is up to 256 bits. The block length is 128 bit. It could be 256, but it's, the block length is 128. It is designed based on the substitution permutation network, and AES is the NIST standard. Mark an incorrect statement regarding the electronic codebook mode of operation. The plain text is broken into blocks. Each of them is encrypted independently. If two ciphertext blocks are the same, then the corresponding nonce is XORed with the nope. This encryption scheme is deterministic. That is very true. Mark an incorrect statement regarding the deterministic counter mode. Oh shit, what time is it? I have to be at office hours until... I have to be at office hours in 2 hours. Shit. Alright, I'm gonna stop this here because I have to do some shit here before I go to office hours.